Okay, so all these problems, I will divide the chapter 6 challenge problem into 3 sections. So now let's start. So the first problem, okay, is G is planting some plants, and some plants are tall and rest are short. Okay, so this is basically it's a category, right? So some are tall, some are short, and then we have different colors. We have the yellow and the green. Okay, so let's do it. The different number, the number of the different plants are in the following ratio. Let's see. The tall green is 8. The tall yellow is 5. The short green is 2. The short yellow is 1. Okay, let's adding parameterize it with using a t. Okay, so now you can see there are, this one is 1080. Okay, so what is the total? So the total is equal to the 16t times t, right? And we know the green is 10 times t equal to the 1080. So we get the t equal to the 108. Then we apply the t equal to the 108 to here. Now we get the total is 1728. Okay, next. So this one is the 40% of the sprig. Okay, so let's do it. Okay, sprig, it spook is peak is spark. Okay, so let's see the sprig is 1. The 40% of this is here, and 25% of the sprig is, then 70% of the sprig is this. Okay, so okay, so we now normalize the sprig, sprig, or spark in the reference to the sprig. Okay, now let's see. So it asks you what percent. Let's see, x percent of one sprig is equal to 5 times the spark. Okay, so we have the x equal 0.35, so it's equal to 35%. I think we need to answer here. Next. So in the recent election of the mayor, so we have 3 candidates. We have S, W, K. Now we have the ratio of the K votes to the S vote is the same votes as the S votes to the W vote. And we know the K vote is 800 and the W vote is 200. So now we can solve it. Okay, so basically from here the cross product, right, tells us the S square equal to KW, K times W is equal to the 16 times to the 100 square. So that's why S equal to the 400. So S equal to the 400. So it asks us the total, right? Total equals to the 800 plus the 200 plus the 400 equal to the 1400. Okay. Next. So each of the 25 square inch. So basically this problem is it cost $130. How much does it cost to cover the entire of the 2,000 square foot? So this is the unit conversion. Okay, so we have the unit conversion is the linear unit. For example, the length. Okay, so if we have the 1 meter, if I have 1 foot of the length, we can convert into 12 inches. Okay, now next is the area. Okay, the area is quadratic unit, right? So if you have the 1 foot and the 1 foot, right, you convert it to the inches, it becomes the 12 and 12. So it becomes the 12 square. This one, the ratio is 12. Okay, now let's converting it. So we have the 2,000 square foot equal to 2,000 times 12 square inch. Okay, then let's count in the number of tiles equal to the 2,000 times the 12 square divided by the 25 is equal to 20 times 4 times the 144. Okay, so we use this number of tiles, right? So the total dollar is equal to number of tile times $130 per tile is equal to 20 times 4 times 144 times the 130. So my calculation is 1497600. Okay, so given a set of the ratio and this one is equal to 1 over k, then we need to find the k, right? Okay, let's see. This is the ratio, right? We can separate them. The first is the yz over the zx is equal to 1 to 2, and the zx over to xy is equal to the 2 to 3. So this one is equal to the y over x, and this one is equal to the z over y. Okay. Now we can kind of parameterize, right? We parameterize by a t, okay? This is the common way we did, okay? So we can see y equals t, then x equals 2t, then z equals the 2 over 3t, right? Okay, now let's see the next is x over yz over the y over zx is equal to z times x squared over the z times y squared is equal to x over y squared is equal to, let's put here, 2t over t, okay, bracket is equal to the 4. Okay, so and we know that 1 over k is equal to the 4, so that's why k equals to 1 over 4. Next, so 99% of the trees in our neighbors are this type of the tree, i.e. type of the tree. The town is planning commission wants to get rid of some trees. Okay, so basically, you know this is the total. Okay, and the eucalyptus is about 99%, and they want to get rid of something, right? They want to. It's originally it's here, and they want to take out something here, right? And now the eucalyptus tree is that about 98% of the tree in our neighborhood. Okay, so now let's take a think about it. If the whole set of the tree is 1, okay, so originally I have the 0.1 of the rest, and I have the 0.99 of something, right? Okay, now we need to get rid of something, right? We get rid of something. For example, it's x, okay? And we still have the 0.1, right? So now we know the 0.99 minus x, right? And over the 1 minus x, right? And it is 0.98, okay? Now let's solving this equation, okay? 0.99 minus x equal to 0.98 minus the 0.98x. Okay, so now we have the 0.01 is equal to the 0.02 x. Then we have x equal to the 1 over 2 is 50%. Next. So it's not a lot. A dealer is currently make a profit of X% of his cost when he sell the goods. If the dealer could get his goods for 8% less, okay, now let's see before, okay? Here is the cost, and here is the profit, and here is the selling price. Okay, so originally, let's see, the cost is 1. Then we make a X%. Then the selling price is this. Okay, now we can make the goods of 8% less. Okay, and we also keep selling the price at this price. Okay, then the profit can increase to here. Let's see what is the profit here. This is the 0.08 plus the X%. That's the profit, right? Now the profit margin, the profit ratio becomes this plus the X, right? Divided by the cost becomes X plus 10%. Then now we have is the 8 plus the X divided by the 0.92 of the percent is equal to X plus 10 of the percent. Now we have so we have the 0.08x is equal to 1.2. Now we get x equal to 15. So yeah, that's about the first section, and we do the second section. Thank you.